The last part, or the third part of proportion and confidence interval, is one of the wonderful things, I suppose, about having a lot of formulas is you can begin isolating certain values in order to determine what, in this case, is a minimum sample size needed to estimate a population proportion in an election. So what we're going to do here is we're going to use these two primary formulas up here, and we know that the margin of error, I'm going to combine these two formulas together, the margin of error is equal to z asterisk, or z sub alpha over 2, times the square root of p hat times q hat over n. So in this situation, what I have to do is I have to isolate the value of n because that determines your sample size. So let's go about isolating the value of n, and then from there it's just a matter of plug and chug. And so we now know that if we the margin of error is equal to z asterisk times the square root of p times q over n. And we now know that, if you start rearranging these algebraically, some people might do this very different, but I'm just going to do it the way I'm used to doing it, I suppose, is me over z asterisk is equal to the square root of p times q over n. So now what I have to do is I have to square each side. And now I have me over z squared is equal to p times q over n. And to isolate n, all we do is we say n is equal to p times q over the square of me over z, and then you have to square that. So that's the way you would manipulate that formula. In this situation, as you might have noticed in your book, when in doubt, and there's no proportion given, we're going to use a proportion or a probability of 0.5. And so n is equal to 0.5 times 0.5. We know what the margin of error is. It gave that to us, which was 0.05. But we don't know the value of z. Here again, keep in mind that this is a z asterisk, right? So that means whatever value you're looking at as far as the confidence level goes, you need to divide that by 2. So kind of more or less coming down here a little bit and doing a side calculation, 1 minus 0.95 is obviously equal to 0.05. 0.05 divided by 2 is 0.025.